Hello everyone, today in this video we'll be discussing the previous questions of 18 CS52 and I'll be going through those questions which are like repeated ones and the topics which you can't miss before your externals of computer networks. Okay, so the previous questions are from these topics and let's get started with the module. And if you like this video, hit the like button and don't forget to subscribe to my channel. So let's go through the overview of each of these modules. In this first you have the module 1. In that it's all about application layers. So in each of these there will be like one or two questions from each of these topic which you need to know. Okay, and here we have the definitions. There are many definitions. Among that, UDP and TCP and multiplexing, demultiplexing, this is important. RDTs, there are 4 RDTs versions and the sequence diagrams, and the TCP, about the TCP, the segment structure and all, and congestion principles. Okay, these are the 4 topics important from module 2. Coming to module 3, we have the routers. About the routers, IPv6, IPv4, very important, different types of routing techniques. Okay, in module 4 we have the network security. Here 2 questions are there about the elements of network security and the techniques of the threats to network security. Okay, and in private key and public key, in both we have 2 methods which we'll be discussing. Both we have theory as well as the numerical. Okay, after that we have the SH algorithm and the firewall. Okay, in module 5 we have these these topics from which the questions are asked. Okay, explain the properties of audio and video and streaming stored video. What are the different types? What is CDN? Give an example, or they can give you any case study as well. And limitations of best effort IP service, removing jitter from the audio, and 2 loss anticipation protocols are there which we'll be discussing. And finally we have the RTP and SIP. So let's get started with the first module. The first module has these questions which you need to know. Okay, so in each of these topics, let's get started from here. The principles of network application. Okay, so the first question is compare the client server and peer-to-peer architecture. Okay, so I request you to open this document in a different device so that you can see the question, and I'll be discussing the answer which is written here. Okay, I'll be just going through the answers and I'll be reading questions from a different device, so you do that as well. Okay, the basic difference between client server and peer-to-peer you can understand by the term itself. Okay, client server and peer-to-peer. Client server means there will be a server here which will have all the data of the clients, and client will be requesting to get the data. Okay, and based on each request of the client, the server will be replying. This is known as client server architecture. Peer-to-peer means there is no fixed client and server. So what we have is many different devices are connected with each other, and each of these can act as a client as well as server. Means if this device has data A, this device has data B. Okay, and this device needs data A. Okay, what it will do, it will ask this device. So this device will become the server and it will send the data. Okay, now suppose that this device has data B and this device wants data B, so it will ask this server. This will become the client and this will become the server, and this device will send the data. Okay, so like that, it's not fixed who is the server, who is the client. They can share the data among themselves. Okay, that's known as peer-to-peer. So here are some points which you can go through, like client and server are differentiated, means who is the client and server, it's fixed, and here it's not differentiated, means anyone can become the client and server based on the request. Okay, and it focuses on information sharing, it focuses on connectivity, and each peer has its own data. There is a centralized server in the client server architecture, and server responds to the request of the clients, and each node can become the server or the client. Okay, and they are costlier than peer-to-peer network because there has to be a centralized database, and peer-to-peer is cheaper because each one can have a part of data which can be shared among themselves. Okay, so that's all basically what you have to do. You can write more points, you can go through the notes, and you have to make a diagram. Okay, and the next question is, what are the different types of transport services provided by internet? Okay, so transport services, we have to see which are the transport services provided by internet. Okay, so what are the transport services? TCP and UDP. Okay, these are the 2 transport layer protocols. Okay, so let's see what are the services under each of these. Okay, UDP means it's a faster transmission, but it's not means it doesn't guarantee that the data will be reaching. Okay, and it's cheaper also. Okay, so that is the service provided by the UDP. And coming to TCP, it is a means reliable data transfer. It's costlier because there is a lot of congestion control and error control. Those checks are going on. Okay, but at the end of the day, the data is reliable transfer. Okay, so that is the that are the 2 services provided by the internet under UDP and TCP. Okay, next question is in the second topic, which is the web and HTTP. Here we have 3 questions. The first question is, explain the general format of HTTP request and HTTP response. Okay, So whenever we open a web page here, how is the web page getting displayed in our computer? When we type in Google some website, at that time the server the request gets sent to the server. So while the request is getting sent to the server, it's not just that what I have typed that is only getting sent. There is a different format for it. In that format, other things will also be included. Okay, so let's have a discussion on what are the things included when the data is getting transferred, and when the data comes back and you can see the website on your screen. How does the data come back? What all the things included? That is the HTTP response message. So what is included here and here, that we'll be discussing now. Okay, so the first one is the request message. In request message, what we basically need, we are just transferring what is our request, means what we need to fetch from the internet, that we are transferring. Okay, so there are four parts that you have to remember. First, in HTTP request message, there are four parts: request line, header line, blank line, and entity body. Suppose that you search how to stitch a shirt. Okay, so that is the query you have here, that will be in entity body. Then the request, what is the method you are using? Get method, because you are getting the data from the internet, right? And URL, which URL you are searching for, which URL you want to go. What is the version? IP version 6 or IP version 4, which you are using. Okay, CR and IFA are just the flags. Okay, and here also the same thing. Header lines, what is the header field name and the value. Here also you have the same things. These are all the header lines which are included in that website. Okay, and yeah, that's pretty much it. What you are searching, which method, which is the IP version, and what is the URL. Okay, so that is the basic format of HTTP request message. Okay, then a request message will look as follows: a get message, because we are trying to get something from the internet. So here you will have the URL, this is the header which will have the domain name, and here you will have other information. Okay, like language and what is the version, and who is going to access that one, means which user is going to access. Those things will be there. Okay, so these three things you have to remember: request line, header line, and carriage return. And you can go through this, you will get more information on what points you have to mention in the exam. And that same what I've basically written in the diagram and explained, you can go through these points. And coming to the HTTP response message, that is also same thing, but here we will have, instead of request line, we'll have status line, because we are sending a status back, right? Like 200 means a good status, means it was okay, fine. Okay, 404 means it's means some error has happened. Okay, so it needs to inform, that response needs to inform whether that data was means the server was able to fetch the data or not. Okay, so that's why we have here status line. The rest three are same, like header line, blank line, and entity body. In entity body, all the data of the website is sent, and in header line we have the header field name and the values, and yeah, those things we have for all the header mentioned in that HTML document. And the blank line is the blank line in between these two. Okay, so a sample response message is as follows. Here we'll have the status line. 200 okay means it's means the what you are fetching, requesting to fetch, that you got. Okay, that means 200 okay. And here you have other information like date, server, lost, modified, content type, and content length. Okay, so the response message also is divided into three sections: status line, header line, and data. Okay, the first one among these three is the status line, and the status line contains three fields: protocol version, status code, status message. And yeah, these are the three things. And the status codes, as I told you earlier, 200 means okay and 400 means it's an error. Okay, and the response message contains 6 header lines, which are connection, date, server, last modified, content length, and content type. Okay, so you have to means explain these means what are the things I have written here, and you have to draw this diagram as well. And that would be sufficient for answering this question. And let's move on to the next one, which is explain how client requests object through web cache. Okay, so the main thing here is the cookies. Okay, cookies means what? If a user enters a website, at that time the user's data will be saved somewhere. Okay, if the user is from India and the user is of age 21 and the user studies in some university, so those are the information. Okay, that information is stored here in the cookies. Okay, that cookies are stored in the web servers of that website. Okay, that is stored here. And when the user re-enters that website next time, based on the previous track of the activity what all the user has done, the user will be shown the recommendations of that. Okay, this you might have observed, right? So that is the cookies. Okay, now the main question is how does the client request object through web cache? Okay, that's the main question. After you have given the definition of cookies, then you have to like what is the what includes in the cookies. Okay, here we'll have the header line, which is in the http request and response message, and cookie file is kept on the user send system and managed by the web browser. Also it has the backend database at the website to store the users information. Okay, so here's how the working of it. The user is requesting something, okay, and the proxy server will have the cookies in it as well as the cache. Okay, so if something is present here, it will be returned back to the user, else it will be served from the main servers. Okay, then it will be returned back from the main servers through proxy server. Okay, so that's the main working, and you just have to explain that in this question. Okay, the third question is explain the http persistent and non-persistent connections. Okay, persistent and non-persistent means, by the term you can understand, persistent means it will stay. Okay, persistent means it will stay. Non-persistent means it will not stay. Suppose that you have to transfer 10 things means 10 images from source A to source B. Okay, in persistent what happens, once the connection is made, the 10 images will transfer, like first image, second image, third image, and so on till 10 images within a single connection. In non-persistent what happens is, if you have to transfer 10 messages, the first message has to be transferred via a single new connection. After this is transferred, this connection will break. You have to make another connection to transfer the next image. That is non-persistent. Okay, this is the basic definition and the difference, and by that you have to expand it in your own words. Okay, so this is the diagram which you have to make for the non-persistent. There will be a request and the response will be there, and after that the file will be transmitted, and this is for the single connection. Okay, and then the transmission line will be broken. Okay, that is for the non-persistent. In the persistent what happens, in a single connection all the things will be transferred. After all the things are transferred, if for some time the transfer of the data does not happen, that means the data has been transferred and the connection will be broken. Okay, that was the three questions under the second topic, web and http. Next one is the FTP. Okay, so the first question is explain the FTP commands and replies. Okay, FTP is used for transferring the files. Okay, so the commands are sent from the client to the server and the replies are sent from the server to the client. Okay, so this is the hierarchy. Okay, so mainly we have to discuss about the commands and the replies format in the FTP. Okay, so commands will be there will be 4 uppercase ASCII characters followed by optional arguments. Okay, for example, user, then username. Okay, pass is for password, list is for list, and retr is for retrieving, stor is for storing. You can give a few examples, and these are the commands. Okay, so used to send the user identification to the server, used to send the password to the server. Okay, so these are the commands. What about the replies? Replies we get back from the server. Okay, each reply consists of 3-digit numbers. For each number there is an associated meaning with it. 331 means username is okay and password is required. 125 means data connection. So give a few examples regarding that. Okay, this is the basic format of the commands and the replies. Okay, the next topic is the electronic mail. So here we have the mail protocol, which is SMTP. Okay, so the question is write a short note on SMTP. Okay, so SMTP is an application layer protocol for emails. Means if you have to send an email from person A to person B, at that time what protocol you will be using is SMTP. Okay, simple mail transfer protocol. Okay, there are few more protocols, but this is the most important one. Okay, so SMTP has two sides, a client side and a server side. Okay, so this is the diagram which you have to make. Here what happens is all the there are users here, and for each user there will be a mail server. Okay, and this means for these are the groups. Okay, each of the users are connected to the mail servers of it, and the mail servers transfer the mails with each other. Okay, so suppose that this user wants to send a mail to this user. What will the user do is, he will send the mail to the server, then the server will transfer to the next server, and this will transfer to the the other user. Okay, so this is how the working, this is what the working of SMTP is, and you have to mention the characteristics and how it works. I just told you now. It works in the same way, and it uses TCP connection. Okay, and these are the characteristics. You can go through it, and that you have to mention. Okay, So that's basically it. And the second question is DNS. Okay, DNS is in the next topic, and in that topic we have we have two questions. The first one is what are the services provided by DNS? Okay, so DNS provides the following services. There are few services, which is the first one is host aliasing. Okay, host aliasing means a host can be have a complicated name, and alias name means that suppose that a host name is like XYZ. Okay, so it can have a easier name like A. Okay, this is the host name. So that is the first service provided by DNS. And the second one is the mail server aliasing. This is also same, just with the emails. And the third one is the load distribution, means that if there are many different means the locations are located at very different means a long distance. So what happens is there will be a distribution of the data. All of these servers will have the same data, and if the user is near that server, he'll get the data. Okay, so that is the load distribution. Okay, and the second question under the DNS is the explain the various steps involved in the interaction of DNS servers. Okay, suppose that a client wants to determine the IP address of a host name like Amazon. Okay, www.amazon.com. Okay, so what he does is, first he will send the request to the root DNS server. Then the root DNS server will transfer the request to the TLD DNS server. This is the server of the Amazon. Okay, and this handles all the other means what are the problems and all those things will be handled by the TLD DNS server. The third step is, since the client wants the host name, means what is the IP address associated with the host name, that is found in the authoritative DNS server. So from TLD it will get transferred to the authoritative DNS server, and from there the client will be getting the IP address of the host name given through local DNS server. If it's already present in the DNS server, means the client had previously accessed that website and got the IP address, it will be sent from here only. That is known as cache, right? So this is how the various DNS server act means interact with each other. And to wrap up, what happens is, first it will search in the local DNS if it's present in the cache, else it will go to the root will transfer to which website it is, and that website's DNS server will transfer to the host name authoritative server. From here the IP address will be sent to the local DNS server, which will be saving a copy of that and as well as transferring to the requesting client. Okay, so this is how the DNS server means interact with each other. And these were the two questions in the DNS topic. Okay, the next topic is the peer-to-peer architecture. The first question, the question which is asked under this topic is explain P2P file distribution architecture. Okay, peer-to-peer we have already discussed what it is. Now here we have to just means shed some light on how the files are distributed and what is the means rate of distribution, which is the better one, and also we have to draw the graph of it. Okay, and we'll be comparing with the client server also. So let's move on. We'll be first describing what the P2P file architecture is. After that, make this diagram here. In this diagram, these are the devices connected. Okay, and one server you will have. That one server will transfer the file from the server to the internet, and from here all the other devices connected can access as well as download that file. Okay, means upload any file or download the file. Now comparing with the client server architecture, there will be one server which will be directly connected to each client. Okay, so let's see what are the differences between each. Okay, so these are the points which you can go through, means what is the length of file is F, and US means upload rate for the server, and so on. Okay, so these are the things defined, and you will be using this in the formula. Okay, so the case one, client server architecture. Here one copy of the file is transferred to n peers. There will be one server, so the server has to transfer the file to n peers, means the n clients connected. Okay, so the distribution time will be nf means how much files are there and how many users are there. Okay, that is transferred here, divided by us means upload rate of the server. Okay, that is the time taken for the server to send to clients. Also the clients need to receive it. To receive it, if the d minimum is the time required to receive each file and the size of the file is f, so the minimum distribution time will be f by d minimum. Now the maximum time among these, this is more or this is more, that will be mattering. Okay, because if this is more, the total time will be this one only. If this is more, the total time will be this one. Okay, so we'll be taking the max value of each of these. That is the time required for distribution in client server architecture. Now let's come to peer-to-peer architecture. Here only one server is there which has to upload one file, so the time minimum time will be f by mu s. Okay, and the peer can receive n number of files. So To receive one file, it is f by d min. To receive n number of files, the total time will be calculated as well as nf will be there. So here we have nf by total time. Okay, this for all the peers connected. So we have three observations here. This is for the server to upload the file. This is for one client to receive the file. This is for n number of clients to receive the file. Okay, so maximum time among these will be means that will be selected for the time required for peer-to-peer architecture. When it was carried out like an experiment for different values of the n value and the time, so this was the result. This for the client server architecture and this for the peer-to-peer architecture. This is a time, increasing packets. As you can see, peer-to-peer architecture is more efficient according to this result. Okay, the last topic which we have is socket programming. Means we have to explain how do you carry out the socket programming using UDP as well as TCP. Here I'll be using the same Java program which was in our lab manual. So I'll be going through it, what all you have to keep in mind and how do you explain this answer. Okay, so first we'll be starting with the socket programming with UDP. In UDP and TCP both, you have to mention two things, client and server. There is a separate program for both of these. How to remember this program, that I'll be telling you now. Remember these 4 points for each of these. Okay, for UDP only. The first is create a datagram socket. Okay, so since we are doing socket programming, we need to create a socket. Suppose that this is the socket. Then get the message and IP address. When you got the message and IP address, then you have to transfer this data. See it's the client, right? You have to transfer the client's request to the server. So you need a packet to transfer it. That's the third point. Packet in a packet and send the packet. Okay, so you'll be sending this packet. And the server side, create a datagram socket. See, this is the socket programming, so you have to create the datagram socket. Okay, for the receiver side, it will be present here datagram socket, and you'll be receiving the message here. Okay, means the packet will be received here, and then unpack the packet and print what is in the message. Okay, so that is the logic of UDP client and UDP server. So here's the program. First we are creating our datagram socket here. After that we are printing that entire message and we are getting the message here in string message. We are getting the IP address. When these two things are there, you will be packing in a packet. We'll be putting the message as well as the IP address, and then we are sending the packet. This is for the UDP client. Okay, coming to UDP server, what we have is to receive the data we need a buffer. Means what is the message coming, I want to save it somewhere, right? So that's why the new byte is here and datagram socket is here. After that we need to receive the packet. So I'm receiving the packet here. I'm creating a packet and means making ready the buffer. Then I'm receiving the packet. Then I'm extracting the message of message from that, and after that I am printing that message. Okay, so this is basically what you have to explain in socket architecture in the top under the subheading UDP. Okay. The next one is the TCP. In TCP client and server, these 4 things you have to remember. Okay, data output stream out and data input stream in. Okay, the next is just remember the keyword socket, and then in out, after that equal to, and finally we have in dot read UTF, out dot write UTF. Okay, so if you remember these 4 things, you will get the overall structure of the program. Okay, these things you have to expand after that. Okay, so see here, the program is starting from here. First we have to write data output stream out and data input stream in, and after that create a socket, the second key point which I have told you to remember. And after that you are just getting the file name here that you can get easily, and after that in is equal to new data input stream socket dot get input stream, and out is equal to new data output stream socket dot get output stream. After that in is equal to in dot read UTF and out dot write UTF, right? So here we have out dot write UTF, the file name, and we'll be reading the file content. The file name is present here. We are reading the file content now. So while reading the file content, if the length is greater than 0, it's means file content is there, else it's an empty file. Okay, the same structure goes for TCP server also, but here some more things are there and a bit slightly different. Okay, but it's better for you that you means like remember in that way. Okay, so let's get started here. First you have to write the data output stream out and data input stream in. The second is the socket. So here we will have a socket, and what is the socket doing? Server dot accept. So you need a server first, so you'll get to know that server is also there. So I'll write this line here. Okay, and after that in out, the same thing as previous one. Then finally in dot read UTF, you're reading the file name. Then out dot write UTF, that comes after that. Here you have out dot write UTF. What you're writing? File content. From where you got the file content? From the file data. From where you got file data? From the file name. In that way you have to remember the connections. Okay, after that this is just the exceptional part here. You can skip this part for now and just remember the main code here. Okay, So this is all what you have to explain, like write the program and explain the approach and what is happening here, and that is sufficient for answering this question. Okay. Coming to the module 2, these are the four main topics, the definitions, RTT, TCP, and congestion. Okay. As you can see, under these topics I have written a few more topics. These are the topics which are covered, means are important under these two topics. Okay. So firstly, you need to know the definition and the difference between UDP and TCP. Okay, and the next one is the difference between multiplexing and demultiplexing. Okay, so the definition and open this means document in a different device, so that I'll be going through to the answers, and you can see the questions. Okay, so the first one is the difference between multiplexing and demultiplexing. Multiplexing means from many parts it will be means joined to a single segment, that is known as multiplexing. Demultiplexing means from a single one it's getting divided into different ones. Okay, that is demultiplexing, and you just have to write this diagram and define what it is. Okay, the next one is the difference between UDP and TCP. The basic difference is these two, like UDP is fast, but it's not guaranteed to be reaching the destination, and the typical applications are VoIP and music streaming. The next one is the TCP. Here you have the slower but reliable data transfer. The typical applications include email and web browsing. Okay, so you can add a few more points. I've just given the overview of the UDP and TCP, and that was about the first topic, the basic definitions. And the second is the RDT. Okay, in RDT we have two questions. The first is the explain the UDP segment structure. So when you're transferring the data from one place to another place, like from source A to source B, at that time you'll be, if you are transferring to UDP, how is it getting transferred? It's not just that the data is getting transferred, many things are along with the data is getting transferred. So what are those exactly? That will be discussing now. Okay, so UDP has the 5 things. You can remember in this way: we are transferring the application data, which is the message, right? And from where we are transferring? From the source to the destination. Okay, and the length of the data, what is the length of the data that is getting transferred, and checksum is for error control. Okay, so these are the 5 things you have to make and explain each of these. Okay, is this the same thing which I have explained now? Okay, and there are versions of RDT. This is the second question, which is explain different RDT versions with protocols, FSM, and sequence diagram. Okay, they can ask you any of the RDTs. Okay, so let's discuss all of the RDTs, but before that let's see why we are using RDTs. In RDT, what happens is UDP is an unreliable data transfer, right? To make it a bit more reliable and to get to keep a track of the sequence numbers and how much data is transferred and what are the acknowledgements we got, to keep a track of these things we'll be using the RDT. Okay, which means reliable data transfer. It is a means a blanket cover on the top of UDP, which will make the UDP a bit more reliable. Okay, so let's discuss the versions one by one. The first version is RDT 1.0, which is the reliable transfer. So here I assume that means the RDT 1.0 assumes that it is a reliable data transfer, the data loss does not happen. So what happens is, this is the source, this is the destination. Here the data is sent in a packet and here it is received. Okay, so that is a hypothetical scenario where the data which is getting sent is 100% getting received. Okay, and it is the characteristics are, it is a reliable transfer and there is no acknowledgement. Why there is no acknowledgement? Because the assumption made at the earlier part is that the data is means 100% will be received. Okay, so acknowledgement is not needed. After writing the FSM and the sequence diagram, you have to write the after writing the FSM and the characteristics, you have to write the sequence diagram. In sequence diagram, these are the packets which are getting sent and received at the receiver's side. Okay, so that's all what you have to do in each of these RDTs. And the next RDT is RDT 2.0, where we have the acknowledgement also. In RDT 2.0, there are two types of acknowledgement: negative acknowledgement and positive acknowledgement. See, what happens is, in the sender and the receiver side, when you send some data, either it can be received or not received. Okay, in the sequence diagram you can see packet 0 is sent from the sender to the receiver, and it is received, so acknowledgement is sent back. The next packet will be sent from the sender's side. But in case packet 0 is not reached to the destination, what happens is negative acknowledgement will be sent. When negative acknowledgement is received by the sender, the previous packet will be resent again, which means packet 0. Okay, so that's what happens in the sequence diagram, and this is the RDT which you have to make, FSM which you have to make. In FSM, you can observe there are two states for sender, means the state 1 and state 2. This is same as automata. In that, what we had is means if you are going to play football, at that time what is your state? Playing. And when you came back to home, what is your state? You're hungry, right? After you ate the food and all, you'll watch TV and then you'll go to sleep. So these are your different states. Like that, only sender and the receiver will have different states based on the what's happening in the real time. So the state one is the packet is with the sender and a packet has to be sent. This is the sender, this is the packet is with the sender. So this is the state 1. After the sender sends the packet, the sender will become in state 2. In state 2, what happens? After he has sent the packet, the sender will be he'll be waiting for the acknowledgement, right? If the packet is sent, then the sender is no more in need of sending the packet because it's already sent. What he's in need of is the request, not request, acknowledgement. Okay, so that is the state 2. Now there can be two acknowledgement, either the negative acknowledgement or positive acknowledgement. In case there is negative acknowledgement, then what you have to do? Resend the packet for the acknowledgement. Else he'll be if you got the positive acknowledgement, he will receive it and do the next means transferring of the packet. In receiver we have one state. If it is a corrupt packet or a lost packet, negative acknowledgement should be sent to the server means sender side. If it is not corrupt, send the positive acknowledgement. Okay, so there is one state here and two states in the sender side. Okay. Coming to RTT 2.1, we have the sequence numbers in case the acknowledgement is lost. Okay, so what happens is, if you can see in this diagram that I have sent a packet here and acknowledgement is received, the next packet will be sent. Okay, now if the packet is not lost but the acknowledgement is lost, I mean if the packet is received here, like in this case, but the acknowledgement was not received, so what will the sender assume? That the packet was lost. Okay, so he will resend the packet. So what will happen is duplicate packets will be sent. So to avoid that, what we can do is the sequence numbers. So there are two sequence numbers. First the packet 0 will be sent, in the next iteration packet 1, the next packet will be packet 0 and 1 and so on. Okay, so in the state 1, the sender will send packet 0 and the receiver will means it will wait for the acknowledgement. If he receives a negative acknowledgement, that means the packet was lost or it was not sent, so it will resend the packet and wait again. Okay, so if he gets the packet, he will come to the state S3 and here he will send the packet 1. After sending the packet 1, it will wait for the next if the acknowledgement is lost or receiving the negative acknowledgement, it will wait for the it will wait for getting the correct acknowledgement. After he receives the correct acknowledgement, he will move to the state 1. So what happens is 0 will be sent here. If he does not receive the acknowledgement, he will resend the packet 0. Okay, then if he receives the acknowledgement, he will send the packet 1. Okay, and the receiver side, what happens is after sending the packet 1, if he receives the wrong sequence number, okay, means after sending the packet 1, means sender has set the packet 0. Okay, first packet 0 will be sent, so the receiver is expecting packet 0. If the packet 0 does not come, packet 1 comes. Okay, because of some issue in the way. Okay, so if the wrong packet comes, at that time he will send the negative acknowledgement and wait for the correct one. Okay, means first sequence 0 should come. If sequence 0 comes, he will move to the second state. Here he will wait for the sequence here he will wait for the sequence 1, and if the sequence 1 does not come, instead other sequence come, he will send the negative acknowledgement, else he will send the positive one. Okay, so coming to sequence diagram, you have to make these 4 diagrams. Here the correct transmission, here the packet is lost, so negative acknowledgement will come here, and the next packet will here also packet 0 will be sent. Okay, sorry, it's not packet 1, it's packet 0 only. Then here it will be, if the acknowledgement is lost, he will be sending the packet 0 again, and if the packet here what happens, the packet 0 is also lost and negative acknowledgement is also lost, so what happens, the P0 will be sent again. Okay, so that was about the RTT 2.1. Here we will have the sequence number, okay, in case the acknowledgement is lost. The next one is the same thing as the previous one, but here we will have no negative acknowledgement. Instead what we will have is ACK1 or ACK2. So let's understand this by a sequence diagram. Here in the case of no loss, packet 0 will be sent, and for packet 0, which acknowledgement should be sent? Acknowledgement 0. And for packet 1, which should be sent? Acknowledgement 1. Okay, so that is no loss case. In case there is a packet loss, for example, if P0 is lost, at that time P0 was not received here, so different acknowledgement will be sent, means acknowledgement 1. So if it is sent another acknowledgement, that means the packet was not received, so he will send the packet again. Okay, in case the acknowledgement is lost, what happens is P0 will be sent here, and here acknowledgement 0 was not received, so it will send P0 again, and P0 will be discarded, but acknowledgement will be sent again. Okay, so that are the three cases which you have to explain. Okay, coming to the sequence diagram, first packet 0 is sent and then it is waiting for acknowledgement 0. If you get acknowledgement 0, he will move to the next state. If you get another acknowledgement like acknowledgement 1, that in that case, what does that mean? Packet 0 was lost. That only he got the wrong acknowledgement, right? So what he should do, he should resend the packet. So that's what he is doing here. Then next case also same, packet 1 is sent, he should receive acknowledgement 1. If he receives acknowledgement 1, he will move to the state 1, else if you get another acknowledgement, he will means resend the packet. Okay, and in the receiver side we have two states here. So the first case, when I send packet 0, what I am expecting is the acknowledgement 0 should be sent back. Okay, so but if I get the corrupt packet or the lost packet, acknowledgement 1 will be sent from the receiver. Okay, if the packet is received, the receiver will send acknowledgement 0. Okay, after sending acknowledgement 0, the next what I am expecting is to receive packet 1 and send acknowledgement 1 if I receive the packet. In case I don't receive the packet, I will send the acknowledgement 0. Okay, so that's what about the receiver side, and we have discussed the sequence diagram. Let's move to the last one, which is the timer. Okay, in RDT 3.0 there is timer, and this is the most important among the 4 RDTs. Okay, so in RDT 3.0 what we have is this is the FSM diagram. Here here it's just that I'll start a timer. Okay, by sequence diagram I can explain. In the sequence diagram, the first is the no loss case, P0 ACK0, P1 ACK1, then again P0 ACK0. Here if the packet is lost, P0 ACK0. If the packet is lost, the machine will wait for some time. If no acknowledgement comes, that means the packet is lost, he will resend the packet. That's the only difference between the previous one and this one. If the acknowledgement is lost, for example P0 ACK0, P1 ACK1 didn't come, he will again send P1. He will wait for some time to receive the acknowledgement. If he doesn't receive, he will resend the packet. And after resending the packet, it will be discarded here because it's already received, and he will send the acknowledgement here. Okay, and in this case, premature timeout. Premature timeout means, observe carefully what's happening. P0 ACK0, then P1 is sent. Okay, P1 is sent and it's received at this point, and it has sent acknowledgement also, but the machine did not wait for means this time. Means it should let the means a receiver send it, means it should wait for some time. But if it does not wait for more time, but before that only it thought that he has not received the acknowledgement till now, that means the packet has been lost. So what he will do, he will send P1 again. Okay, so acknowledgement is coming here, then he will send the P1 before the acknowledgement. When he receives the acknowledgement, at that time he will not do anything, he will send the packet 0, means P0 P1, the next packet is P0. Okay, after receiving acknowledgement, he will discard P1, means P1 is resent here, that will be discarded here, and ACK1 is sent, that will be received here, and packet 1 will be sent again. Okay, so no, packet 1 will not be sent here. Here nothing will happen. Then what will be happening is from here. Okay, P0 is received, which is the third packet, and then ACK0 is sent, and from here the next transmission will happen. Okay, to wrap up, what happened is P0 ACK0 and P1 was sent, and before receiving ACK1, the machine sent P1 again, so that acknowledgement came here. That will not be means that will not make any effect. P1 will be discarded and ACK1 will be ignored. Okay, so when the ACK1 came here, then P0 was sent, and from here the transmission will resume, means normal transmission will resume. Okay, so these are the 4 cases which you have to draw the sequence diagram and explain. Let's see what is the difference in the FSM. So here also we'll have 4 states, one for packet 0, packet 1. I have sent the packet, packet 0, I have started the timer. If I get the ACK1, that is the wrong ACK, that means the data was corrupted or lost in between. So what I have to do, I have to resend. Okay, I'll not resend suddenly, I'll wait for some time. If the time is out, I'll restart the timer and resend the packet. Then I'll wait again for the acknowledgement. Okay, if I receive the correct acknowledgement, I'll move to the next state, and I'll do the same for the packet 1. Okay, same things here, it will be doing for the packet 1 also. Okay, then again if I get the correct acknowledgement, which is ACK1 in this case, I'll move to the starting state again. Okay, so this repeats for means how many packets are there, P0, P1, again P0 and P1. Okay, coming to the receiver's side, here we have the two means the states for receiver. This is the same as previous one. Here I have sent packet 0, so I'm expecting acknowledgement 0. So acknowledgement 0 will only be sent when I have received the correct packet. If I don't receive correct packet, I'll send the acknowledgement 1 to the sender. Okay, that will indicate the packet has been lost or corrupted. So ACK0 it will come here, then if it's correct packet it will send ACK1, else it will send ACK0, and that denotes the packet is corrupted or not received. Okay, so that's all what you have to mention in the RDTs and explain first the FSM and what are the characteristics, and after that the sequence diagram. Okay, the next question is another TCP. Here we have the question, write with any diagram explain TCP segment structure and fields. Okay, so TCP means transmission control protocol. Okay, so here as the previous one, like in UDP also this is the same thing here. What you are sending start from here, the data is being sent from the source to the destination, and we are using two things to make it more reliable data transfer: sequence number and acknowledgement number. And here you have options also. If you can remember these four things, the 50% is done. Options, data, source to the destination, sequence and acknowledgement number. In between you have the flags and the header files that you can learn later. Okay, so this is the overall structure, and these are the fields which I have explained. The name is sufficient for explanation, like source and destination, what is the data, what is options, acknowledgement and sequence number. That is the definition given here, and what are the different flags, those definitions, go through it. And this is about sequence and acknowledgement number. That's all what you have to explain is make this structure here, and after that explain what are the each of these fields. Okay, the next question is under the topic congestion control. Here we have the first question, what are the principles and ways of congestion control. So what is congestion? Congestion means if there are two sources like source A and source B, and there is one path only. Source A is sending some data here, and source B is also sending some data. So there will be congestion here. That is known as congestion. Okay, so how to control it is by using the different principles and techniques. Okay, so in the first scenario there is two senders and a router with infinite buffer. So whatever data is being sent from here to here, at that time the data is being stored here. Means if the buffer capacity is means it's not limited. So what happens is whenever you send the data, if the receiver's capacity is 10, if you are send 11 packets, so 10 packets will be sent here and the one packet will be stored here. Now continuously you are sending 10 more packets that will be stored here. When this is processed and becomes empty, then the next 10 packets will come from here. So here we have more space, so that is known as the first scenario, which is two senders, router and an infinite buffer. This is the hypothetical scenario. Okay, the next scenario is where we have two senders and the router with finite buffer. Here the buffer is finite, so if the buffer gets full, like in this case if it gets full, at that time some packets will be dropped. So the dropped packets will be eventually resent by the sender. Okay, so that is about the second scenario. And third scenario is like how to have the finite buffer as well as reduce the probabilities of packet loss. So how do we do that is we have four clients connected here, and here we have the buffers, and here we have the the queue for each of these. Okay, so these are connected. If I want to send data from A to C, I'll be transferring in this way or this way. Now the thing is that the advantage which I have here is if I have to send the data from A to C, okay, if the this buffer is getting full, that can send the data to this buffer, and if this is also getting full, in meanwhile what will happen is it will get transmitted here and it will start processing it. Also it will get transmitted here and process will start. So data packet loss will be very rare in this case, and this is the best and efficient way for handling the congestion. Okay, so that's what I explained here, and there are some approaches to network congestion, means the congestion control. The first it is divided into two parts. The first is the network does not provide assistance. Second is network provides assistance. Okay, so when the network does not provide assistance, what it should be means what the device is supposed to do is congestion must be inferred by the end systems based on the observed network behavior. Okay, segment loss is taken as an indication of network congestion, and the window size is decreased accordingly. Okay, if there is a segment loss, it means there is congestion, and then the window size will be decreased. So it will send a limited data which will be processed. Okay, so data will not be lost. That is when the network does not provide assistance. Okay, the second case is when network provides assistance. Here we have the direct feedback. This is called the choke packet. So the network will send the choke packet to the client who is sending the data, so that it gets to know there is a congestion and it will reduce the speed. Second is the router markers. A router will mark a packet that the data means the congestion is there. That packet will be sent to the sender, and that indicates that the congestion is there, so the data rate will be reduced. Okay, so these are the two types, and in one of these we have ATM ABR. ATM means asynchronous transfer mode, and ABR means available bit rate. Okay, in asynchronous transfer mode, what happens is, asynchronous means what? It can wait and send. Okay, means it is not, means the rate of sending is not constant, it can vary. Okay, so based on how much space is there, like same case goes for available bitrate also. How much bandwidth is available, how much bitrate is available, based on that the data is getting transferred. If means there is a congestion, it will reduce the bitrate. If there is a means free space here, that will be utilized. Okay, so these are the two ways, ATM and ABR congestion control. In that we have two types of cells: data cells for transferring data, and RM means resource management. Okay, in these two cells we have some flags which indicate whether there is congestion or not. Based on that the rate will be reduced. Okay, so you can go through the ways in which we can utilize the flags. Okay, in module 2 there is a numerical which is frequently asked, so let's discuss on how to solve that numerical. Okay, so the question is, suppose two measured sample RTT values are 106. Okay, so this is the sample measured values of RTT. I am denoting as SRTT. Okay, so those two values are 106 and 120. Okay, so these two are the RTT values. Now the first question is, compute the estimated RTT after each of these sample RTT values is obtained. Means for this one we have to calculate ERTT, and for this one also. Okay, assume alpha is equal to 0.125 and beta is equal to 0.25. Okay, and the estimated RTT just before the sample values is given as 100. Okay, so initial RTT is 100, and we have to find what is the estimated RTT for each of these. Then in the next question, compute DRTT and assume beta is equal to 0.25 and DRTT is equal to 5 ms. So DRTT, initial DRTT is 5 ms, and before the first sample is obtained. Okay, so these are the data given. I have written here the data which is given to us. So first what you have to calculate is ERTT, estimated round trip time. Okay, so the formula is ERTT is equal to 1 minus alpha into the previous RTT plus alpha into SRTT. Okay, so the initial RTT value is 100 ms and alpha is equal to 0.125 and beta is equal to 0.25. Okay, the first SRTT value is 106. So what we have to do is, you have to just substitute ERTT value here. Okay, so which is the initial ERTT value? 100. Okay, so I have substituted 100 here, and 1 minus alpha, 1 minus 0.125 and alpha into what is the first SRTT value? 106. Calculate this answer, take the round off answer, and that's your ERTT value. Now you have to calculate DRTT value. The formula is DRTT is equal to 1 minus beta DRTT into DRTT plus beta into the mod of SRTT minus ERTT. This is which ERTT? Not the initial one. What answer you get here? What I mean is, this is the value which you are going to take here. Okay, so I have substituted this one here, and SRTT is same 106 that I have written here. Beta is 0.25, DRTT initially it's 5, so it's we have to write 5 here, and substitute the value of beta here and calculate the answer. So here will get the answer as 5. So that's the DRTT value for the first sample. Okay, for the first sample which is 106, the ERTT value is 101 and DRTT value is 5. Same thing goes for the next one also. In next one the ERTT value will be 101. Okay, this is the ERTT value which you have to consider. Also the SRTT value is 120, which is given in the question, the second sample value, and DRTT value we got here 5, so we are taking here as 5. Apply the same formula and find out the answer. You'll get 103.4 and 8. Okay, so that's all what you have to do in this numerical type, and that marks the end of the module 2. Coming to module 3 of computer networks, we have these 4 main topics: router, IPv6 versus IPv4, routing, and hierarchical routing. Okay, so here we have 3 protocols: BGP and routing information protocol, and open shortest path first. Okay, this come under Inter AS and Intra AS. In routing we have LS, which is link state algorithm, also known as Dijkstra's algorithm. DV is the distance vector, also known as Bellman-Ford algorithm. So we have the algorithm you have to write, also you have to write the solve the problem, the graph which they have given, and we'll be discussing how to remember the algorithm and how to solve the problem also, one example for each of these. Then coming to architecture, means router. The architecture of router means there's a diagram here that you have to make and explain each of these components here. And switching techniques, there are 3 techniques. Okay, that's the important thing in router. In IPv6 versus IPv4, you have to make the segment structure, addressing, and transforming from IPv4 to IPv6 and vice versa. So let's get started with each of these. The first question is define routing. What are the goals of routing algorithm, and explain the routing architecture. So routing, what does routing mean? It refers to the route or the path taken by the packets as they flow from the sender to the receiver. Routing means just selecting the most optimal path. The goals of this algorithm include cost effective and time effective and most optimal path. Okay, and what is the architecture of routing? You have to make this diagram. After that, you can observe four components here: the first component, second component, third, and fourth. So let's discuss each of these. The first one is the input port. All the messages and the packets come and stand in a queue, and after that it gets transferred to the switch fabric. And after that transformation here, it will be coming to the output port. It will be going to the destination. Okay. So you got to know about the input port and the output port. Routing processor just processes the whatever is happening in the routing, and coming to switch fabric, it will decide which path to take. Okay, so that's what about the 4 things which you have to explain. And coming to the next question, which is explain the switching techniques. In switching techniques, there are 3 techniques: the memory switching, bus switching, and cross bus switching. Okay, so what are the differences between each of these? There is the input, there is the output, and in the memory what happens is the read and write operation happens in the memory. Means any packet comes, it will be stored in memory, and from there it will be sent back whenever it is needed to be. And CPU is the routing processor. Here the routing processor is the CPU. Okay, that is the memory switching. The next one is about crossbar switching. Crossbar switching, each of these input queue is connected with each of these. So if you have to transfer the data from this one to this one, I'll be using this path, and there will be parallel transmissions as well. Okay, so if I have to transfer from here to here, that both can happen at the same time. So that is the advantage of crossbar switching. And the last one is bus switching. In bus switching, there will be no routing processor. If you want to transfer the data from this one to this one, you'll be sharing it to bus, and you'll be having a label. Based on that label, it will be transferred to which destination it has to go. Okay, so that is the bus switching technique. These are the 3 type of switching techniques that comes under the first topic, which is router. Okay, the next one is the IP, and in IP we have 3 questions. Draw the IPv4 and IPv6 format of datagram and explain the significance of each field. After that, you have to compare IPv4 and IPv6. Finally, you have to mention the methods of conversion from IPv4 to IPv6. Okay, so let's get started with the first question: the datagram format of IPv4 and IPv6. So in the datagram format, it's a quite big one. So what you have to remember is data and options. Okay, what you're transferring the data, and options is just the optional flags. Okay, and from where you're transferring to where, from the source to the destination, right? The top part is just the different flags and other information which you'll get to know as we go through the definitions. Okay, so here the data which is getting transferred, header contains the information of routing and delivery. Version is IPv4 or IPv6. Header length is in this space you will have the length of the header, and types of service means which type of service you are going to adopt for the transmission, and it consists the reliability and the cost information as well. And datagram length, what is the length of the data, means how much size data you are transferring. And identifier flags and all are used for why flags are used. Flags are used for different types of, like, options will be there in between to switch on or switch off. That will be decided by the flags. Okay, coming to IPv6 also, it will be, it is the same format as the previous one, but some this is the lesser, means in the previous one there are more number of terms, right? Here less terms are there. Okay, that's what I'm trying to say. And data is here, and from source to destination, here we have lesser number of flags. Okay, so you can easily understand here, like the version, means IPv4 or IPv6, and what is the next header, what is the hop limit, how much hops are there, what is the payload length, means what header you are going to transfer, that what is its length, and the flow label means it denotes from which source to which destination it has to go, and the last one, traffic class, it denotes the class of means from which class it's going to be transferred, it denotes the priority. Okay, so that's what about the IPv6. And coming to the difference between IPv4 and IPv6, IPv4 is 32-bit and this is 128-bit, and fragmentation is done, and here it's not done, means here it's done by the routers as well, here it's done only by the sender, and it does not have the quality of service check, it has the quality of service, and it includes options for up to 40 bytes, it has more than 40 bytes, it includes a checksum here, it does not include a checksum, ARP is available, but ARP is converted to NDP. Okay, and broadcast is available here, it's not available here, and it's manual configuration and it's automatic configuration. One more point you can add is that here we'll be using the somewhere here we'll be using the colon and double colon somewhere, okay, that you confirm, but that can be also added as an example. Okay, so these are the points which you have to mention, at least 5 points you have to mention and explain. Okay, so that was about the second question. Coming to the third one, how to convert from IPv4 to IPv6. Basically there are two techniques, dual stack approach and tunneling. In both of these, let me tell you what is the pattern. Here what happens is, in both of these the same diagram. Okay, here what happens, from IPv6 it's coming, and here in between there is IPv4. What happens is the data of IPv6 is copied and stored in IPv4 data format, and that is getting transferred here, and again data is copied from here to here. Okay, means the format will change but the data will remain same. That's how the transfer happens. Okay, that's the main point, and you can elaborate it in your own words. Okay, we are remaining with two more topics, which is routing and hierarchical routing. First, let's discuss what is the LS algorithm and DV algorithm, how to remember the algorithm, as well as we'll solve an example for each. Okay, the first one is the LS algorithm, also known as Dijkstra's algorithm. Here what we do is we will calculate the least cost path. Okay, so these are the terms which are the which we will be using in the algorithm. So don't worry, we'll be discussing what are these terms in the problem as well. So here how you have to remember is, first you remember this one. Okay, for all nodes in V, what we are trying to do is, firstly when we'll have the path here, we'll be assigning the values of each path from each path to each path. Okay, so that is the direct cost. If there is no direct link, means between like there are three nodes here, from this node to this node there is no direct link, so at that time the cost will be infinity. After you have initialized this one, you will be looping it. In loop what you will do, each time you will iterate to the different neighbors, and you will see if the current distance is more or current distance plus the cost, that is more. Okay, and in that way you will be updating the values of dv until n dash is equal to n. N dash means the new nodes will be adding to the empty list, and if that becomes equal to n, that means all the nodes are covered. Okay, initially n will only have the starting node, which is u. Okay, so this will be understanding more when we solve an example. So let's solve this example here. Find the shortest path from the node 1. So from the node 1 we have to start using the link state algorithm. Okay, so your first step will be what, here you will have to see, this is the source node. Except the source node, how many nodes are there? These nodes are there except the source node, so just mention those nodes, means 2 3 4 and 5 and 6. 1 you should not mention because that's the source node, and you will be writing 1 here. Okay, 1 will be written here, and now you tell me what is the path from 1 to 2. The first thing is you have to fill these empty spaces here, right? So for that what you have to do is you have to check what is the path from 1 to 2. From 1 to 2 there is a sorry, not this one, from this one here, from 1 to 2 there is a direct path 3. Okay, so 3 is the cost, and from which node you are coming? I am coming from node 1, so I'll be writing 3 comma 1. Again, what is the cost and from which path which source node I am coming? 1. So 3 comma 1 will be written below 2. Like that we'll be doing for all. Suppose that we are calculating for 1 to 6, there is no direct path, so in that case we'll be writing infinity. After you have written the first row, select which is the minimum, 3, 2, 5 or infinity. 2 is minimum, so 2 corresponds to which node? 3. So I'll be writing 1 comma 3 here. Then what I will be doing, whichever node I select, that one I will be not writing again. Okay, so the remaining nodes are 2, 4, 5 and 6. Now from 1 and 3 both I will be checking if there is any path to 2, 4, 5 and 6. Okay, so from 1 and 3, is there any path to 2? Yeah, there is a that's the same path. From here there is no path to 2, but here this is the previous path only, so I'll be writing the previous value. After that I'll be checking for 4. Okay, I've written 4 comma 3. Let's see why. See here, from 1 the direct path is 5, but I have selected 3 also, so I can go through this path. In this path I'll get a shorter path, 2 plus 2 4, so I'll be updating the cost as 4, and from which node I am coming, 3. 4 comma 3 will be written below this one. This value is updated to 4 comma 3. Like that only I'll keep on doing, and I'll be selecting the minimum ones, adding it, and I'll be checking from each of these nodes if I get a shorter path. In that way I'll fill all these, and the answers is this one, the last values in each column. Okay, that's my answer. So how you'll make the destination, you have to make this table here. You have to write destination as well as link. In destination you will write 2 3 4 5 and 6, except the source node, all the nodes will be written here. Now to reach to 2, how did I reach? See here, to reach to 2, what the path I had chosen is directly from 1 to 3, 1 to 2. So that was my path, so I'll be writing here 1 comma 2. Okay, and to reach to 3, 1 to 3. Okay, so I'll be writing here 1 to 3. Now to reach to 4, what path I had taken? 1 3 and 4. So directly connected with 1, what is the value? It's 3. So I'll be writing 1 comma 3. Okay, if this was the path which is the shortest, I'll be writing 1 comma 4. All you have to do is just see from 1 to which path it is connected, and from there it is going. Okay, means suppose that this is also a valid path, okay, which I will initially choose. Okay, means eventually choose. So in this path I'll be just seeing if I have to reach from 1 to 5, I'm going through this path. So what is the two numbers which I will write? I'll be just writing 1 first, because I'm starting from 1, and which is the path connected to 1 through which I'm getting to 5, that is 3. So I'll be writing 1 comma 3 for 5 also. Okay, so for 5 I'll be writing 1 comma 3. For 6, how I'm reaching? The shortest path is through 3, right? This is the shortest path, so there also I'll write 1 comma 3. After I've written these paths here, then I have to make the graph here, like which is the shortest path from 1 to 2, how I reached in this path, and 1 to 3, this is the path. From 1 to 4, I went to this one, 1 to 6 and 1 to 5. So this is just the this is just the diagram which you have to make, denoting which is the shortest paths. Okay, so that's all what you have to do in the link state algorithm. And moving on to the next one, which is Bellman-Ford algorithm, or also known as distance vector algorithm. Here what you have to do is just write the basic information of it, like it's iterative, asynchronous and distributed. These are the points explaining each of these terms, so you can go through that. And after that, the basic idea is this one. Okay, so to write the algorithm, you have to this you can write explaining in your own words also, like what is the algorithm about, and this is the algorithm. Okay, so let's see how to remember this algorithm. Okay, this is the initialization part, and after that we have the loop part. So let's see what is the initialization part. Here how many loops we have? 3 for loops we have. Okay, and what we are doing in the first for loop, for all destinations y in n, d of x y is equal to c of x comma y. So just remember that if you have to initialize the table, you will be initializing the direct paths. Okay, so that is about the first for loop. The second for loop is, in the second for loop you can find a dw of y is equal to question mark for all destinations y in n. Here if the neighbor w is not initialized, means there is no direct path, you will be writing dw y is equal to question mark. In the third for loop, for each neighbor in w, what you have to do is dx is equal to dxy for all y in n. Okay, this is just you write 3 times, you'll remember it. Okay, that was the initialization part. And the loop part is also same thing. See here, what is the similarity which you can find? The last one which you can find here, the overall structure is this just written wait until I see any change here, so this you can skip. Just you have to write for and if. Okay, in for loop what you can find, in in if loop, what in if condition what you can find is this one. This is the same thing as the previous one. See here, if you learn this once, you can write it in 2 places. Okay, so this is the important equation. That's the same thing here, just the difference is that to all neighbors. In the last one to all neighbors, but here to w. That's the only difference. Now let's see how to remember this one. Basically what we are doing in Bellman-Ford, we are checking if I am getting a shorter path through other node or not. Means there is a direct path, this is shorter, or through other path, this is shorter. So that's what I am choosing, which is shorter, means minimum value. C of x comma v, which is the direct path, that is minimum, or C of x comma v plus d of v phi, which is minimum. Okay, here I had to write d of v y as well, so that I have missed. Anyways, that's the minimum path here between both of these. Okay, that will be selected. So you got a basic idea of how to remember these points, right? So that's how you write the algorithm and explain the about terms in your own words. Okay, now let's solve the problem in it. So this is the problem where we have the graph given to us. We have 3 nodes here, and in these 3 nodes the cost of means from one node to other node is from 1 to 2 it is 2, from 1 to 3 it is 1, and 2 to 3 it is 7. To solve this using Bellman-Ford algorithm, you have to make each means how many nodes are there? 3 nodes are there. Make 3 tables for each node. In each iteration you have to make that many tables. Okay, so how you will fill the table values? Right here 1 2 3, and here also 1 2 3. Okay, now in the first table what you have to fill is only the first row you will fill. See the diagram and fill, rest all should be infinity. And in the second table the second row only will be filled, rest all will be infinity. Third also only third row, rest all will be infinity. Now how to fill these values? This you might know. 1 to 1 it is 0, 1 to 2 it is 2, 1 to 3 it is 1. Means see here 1 to 1 it is 0, 1 to 2 it is 2, 1 to 3 it is 1. So that cost values will be filling here. Same thing goes for 2 and 3 as well. Okay, now coming to the next one, iteration 2. Here what you will do, here you will not fill the first row because it's for first table. You will not fill the first row. Second table you will not fill the second row. Third table you will not fill the third row. What you will fill instead of that is the second and the third row. Here you will fill first and the third row, and here you will fill first and second row. Okay, now how to fill the second and third row here? The second row values will be taken from the table 2. The third row values will be taken from the table 3. This you will fill. After filling this one, then only you have to fill the first row. How you will fill first row is, now since there is one iteration over, you can pass through 2 nodes. Means from 1 to 1 it is 1 only, 1 to 2 it is 2, shortest path, 1 to 3 it is 1. Okay, you will be having the same values. So I am filling here the same values 0, 2 and 1. For the second table, I can go through 2 nodes. So I have to fill the values 2 to 1, 2 to 2, 2 to 3. So let's see, from 2 to 1 the shortest path is 2 only. From 2 to 2 the shortest path is 0. From 2 to 3 this is the initial path which I had written, but since it's the iteration 2 I can pass through 2 nodes. So if I pass through 2 nodes, this one and this one, I'll get a shorter path. 2 plus 1 is 3. Here I am getting 7, here I am getting 3. So I'll select 3. So after selecting 3, I'll be writing 3 here. Same thing goes for here also. The change that will be happening is from 3 to 2. Here I'll be writing 3 instead of the previous value 7. Okay. After that happens, means if there are 3 nodes, you will be performing at max 2 iterations. That is over. So what is the answer is this one and this one. For the table 1, this is the answer. Table 2, this is the answer. Table 3, this is the answer. You just have to make a new table here, like final table. Inside that, in the first row write this one, second row write this one, and third row write this one. There also you'll have 1 2 3 here, and here also 1 2 3. Okay, that's the final table. And after making the table, you have to make the graph here. So in this graph, we will be removing this one. We just have to reach the all the nodes, and the shortest path is from here to here and from here to here. Okay, this is the shortest path to connect all 3 nodes. That is the final graph which you have to make in the distance vector algorithm. Okay, coming to hierarchical routing, we have 3 algorithms or protocols, which is routing information protocol, open source, open shortest path first, and this I'm not sure what is the full form. This is the BGP algorithm. Okay, so here the two classifications are Intra AS and Inter AS. So let's discuss what is the hierarchical routing protocols. Okay, so in the hierarchical routing protocols, firstly, why do we need hierarchical routing protocol? In hierarchical routing protocol, it will have all the routers following the same algorithm. Okay, 2 problems of simple routing algorithm. As the number of routers increases, overhead involved in computing and storing routing information increases. Okay, so first one is the lack of storage. Second is the able to administer the network, run and administer the network on its own. That is not possible in the simple routing algorithms. So that's why we have to use hierarchical routing algorithms. Now here's how it works. In this, what will be happening is we'll be having different groups here, and each of these group will be having some rules here, means rule number 1, rule number 2 and rule number 3, and all of these nodes will be following the same rule of the group. Okay, and each of these group will also be connected. The this type of connection is known as intra AS, means these groups, inside these groups connection, and the connection between the two systems is known as inter AS. AS means autonomous system. This is one autonomous system, this is another one, this is another one. Connection between the autonomous system is known as inter AS. Okay, so there are two routing protocols in the first in intra AS, which is the routing information protocol and open shortest path first. In routing information protocol, there are maximum as 15 means what is the cost associated with that, means 15 hops will be there. Okay, each link has a cost of 1. So like this the paths will be there in the autonomous system, and here the maximum value is 15. Okay, and the data will be transferred using the routers, and each router will be having the routing table to see and transfer which node it has to transfer for the next one, and can send messages by the response and request means format. In that way it will be transferring the messages. That's the main points which you have to write in routing information protocol algorithm. Okay, the second is the open shortest path first. This is for the means if there are more number of nodes than 15, we have to use this one. So it comes with some advantages like more secure. It has multiple paths for the same cost, means multiple same cost paths. So if one path is blocked, other paths will be available with the same cost, and the information can be transmitted using that paths. Okay, also it has the support for unicast and multicast, and the support for hierarchy within the single routing domain. Okay, so the working is as follows. Firstly, the router constructs the topological map of the entire AS. Okay, after that it runs the Dijkstra's algorithm to find the shortest path. After that when it finds a shorter path, it will broadcast the means the updated value to all the other tables. Okay, that's all what you have to write. Make the diagram and explain the important key points. And coming to the next one, which is inter AS connecting connection between autonomous system. For that we use BGP. Okay, so the main objectives of BGP is obtain the subnet reachability information. Okay, after that propagate it and determine the good routes to reachable and follow the AS policy. Now there are two types of session. External BGP refers to two autonomous systems. Internal BGP refers to autonomous system inside the means the algorithms followed inside the autonomous system. Okay, so this is a diagram which you have to make, and also there are path attributes and routes. The two important attributes are AS path and next hop. Okay, AS path will determine which path to be chosen, and next hop will determine where the next means from one packet, this one router and another router. From this a packet has come here, that packet has to go to which one, this one or this one. That is the next hop. Okay, that will be determined. Also in the route selection, there are two, if there are two or more routes with the same prefix, the following elimination will be invoked sequentially. Here if there are two nodes which are having the same label, at that time what will happen is the routes are assigned to the local preference. There will be a preference table in the routing table. Based on that the next hop will be selected. Okay, also they will check which is the shorter path, and that will be selected. Okay, in case if more than one route still remains, the router was means the router uses the BGP identifiers to select the route. Okay, and the last topic is the routing policy. This also you have to mention here. There's a provider network and customer network. In customer network, X, Y, W, X and Y is there, and in the provider network A, B and C is there. Okay, so here you just have to say which are the different providers and the networks here. So like the autonomous systems, stub networks and backbone provider networks will be there. Okay, so if data is to be transferred between the provider and the customer, so that will be happening based on the different protocols which is based on different network types. So yeah, that's all what I have to mention, the routing policies under the BGP. Okay, coming to module 4 of CN, let's first go through what all topics are there. Okay, So the first topic is about the elements and what are the threats to the network security. So the brief overview of what are the elements of network security and how do the attackers attack. Okay, so these two are the main questions, and after that we have the two techniques to secure the network. Okay, so those two techniques are cryptographic techniques and authentication techniques. The rest of the module is regarding these two techniques. Okay. So the authentication technique has the SHA algorithm, and after that we have the firewalls. Okay. So these two things come under authentication techniques, and cryptographic techniques has two categories. Okay, first is the private key and second is the public key. Okay, by using private key means a single key. Okay, and public key means using two keys. And in private key it is much cheaper and easier to install, but it is more vulnerable to attacks. Okay, but in public keys it is more secure, but it's more costlier also, and it takes more time because we have to calculate more mathematical functions. Okay, so these two are the categories, and in each of these we have types. In the first we have DES and AES. Okay, so from exam point of view, AES is not much asked. You can go for DES, the theory and one numerical. Okay, we'll be discussing that theory and numerical in the upcoming topics. And in public key we have RSA and Diffie-Hellman. Okay, so in these two we have the algorithm as well as the numericals. So we'll be discussing few numericals about these two topics in the upcoming module. Okay, so this is all the overview of this module. So let's get started with the first question, which is the elements to the network security. What are the elements of network security? There are mainly two elements: confidentiality and authentication. Authentication. Okay, so confidentiality means the information should be secure. Okay, so suppose that there is a user A. User 1 is going to send to user 2 a message that I am user 1. Okay, so if it is not confidential, other people can also see it, and other people can modify it and send it. Okay, so that's what the confidentiality is. And the second is the authentication. Authentication means even if the message is secure, how am I sure that the user 1 is only sending? It can be that the user means 3 or user 4 they also can send it, right? The message is secure, but how can I know that at this part this is the user 1 only? For that we will use authentication techniques. Okay, like using SHA algorithm and using firewalls we can do the authentication techniques. Okay, so that was about the two elements of network security. You have to just define what are those and make this diagram here. Okay, this is without confidentiality and using the confidentiality here. Okay, so here what happens is by using two keys we will secure the message. It will be encrypted and the normal people can't read it, and the decryption will happen using the keys, and the receiver will only able to read the message. Okay, so that was about the confidentiality and authentication technique. In continuation to the first question, we have been also asked to explain the threats to the network security. Okay, so threat to the network security are different types of attacks. Okay, so there are mainly four types of attacks. First, remember this one. Okay, if you remember these four, you can easily expand it. Okay, DNS means what? Domain name system. Okay, domain name system, and routing table is nothing but we'll have a table here, due to which the packet will check this table and go to the next hop. Okay, and packet mistreatment is just that the packet will be there and the information will be changed, or the packet won't be sent further. Those things will happen. Denial of service is that just the means whatever website is providing the service, that website will be made to crash. Okay, so that are the four types of attacks. Okay, so the points which you need to keep in mind for these four attacks is that in domain name system mainly we will have an index. In this index we have the website name here and as well as the IP address here. So what happens is the person, the hacker, what he does is he will change the domain names, or he will change the IP address so that the person will go somewhere else by accessing the address. What he will do is he will take the information from that address. Okay, so he will change the information from that, and he will leak the information. Also he will change where the place the person is supposed to go. Like for example google.com is there. Okay, so the person can change the domain name like OOO, so that time the person will reach to other websites. Okay, so that is the main points in the DNS hacking. Okay, so it is known as information level attack, where the information is leaked or changed, and masquerading attack means taking the information and changing it in the man in the middle attack, and information leakage, Also in the domain hijacking, it is means the website name is changed, so the person is forced to enter a attacker's website. Okay. So these were the 4 points in the domain name system hacking. The second is the routing table poisoning. So here the routing table is the basically the table due to which the means it has all the information of other nodes. Okay, from where the a link has to go, where those things will be there, and the cost of each link. So there are two categories in it. The link is attacked or the router is attacked. If the link is attacked, the person goes to other places, and if the router is attacked, the person the hacker changes the information in the table so that the link values will be changed. Also the cost associated with these will be changed. Okay, so these are the 2 main types of attacks in the routing table. Okay, link attack and router attack. And the next one is the packet mistreatment attack. Packet mistreatment means if the person A is sending to person B a packet, okay, in that information is there. If this packet is if the user gets the packet, means the hacker gets the packet in between. At that time what happens is he can either change the information, or if he even forwards the packet, he can add some other values and modify and send, or he can even add virus to it, or he can duplicate the packets and send multiple time to the same person, right? Or he choose to not send only. Okay, means he not allowed to reach the destination. He may not allow the packet to reach the destination. So these things can happen in the packet mistreatment attack. Okay, the last is the denial of service. Denial of service means the user is prohibited from accessing the normally provided services from the web. This happens due to 2 techniques. Okay, the first one is the buffer overflow, or sending a large number of queries, flooding the messages from one place to other place. Okay, so this is the destination and this is the source. The first technique is from the source the multiple messages and the queries are sent, so that the destination will be overburdened by it and it will crash. Okay, or that is the first one, single source, and second is the distributed network. So parallelly many people will be sending the queries to it, so that then the system will be crashed. Okay, so that are the basically the 4 threats to the network security, these 4 types of attacks. Okay, so that was the first topic, and the next one is what are the 2 different techniques used to protect the network from attacks. Okay, the 2 techniques are cryptography and authentication. Okay, this I have discussed what is cryptography and authentication. Okay, cryptographic is the process of transferring a piece of code, like if it is ABC here, it is transferred to some other unreadable format. Okay, like hash, exclamatory mark, and X and all. Okay, so I don't know what is this, but at the receiver's end it will be again decrypted as ABC. Okay, so that is known as cryptography. And in cryptography we use XOR. Okay, so let me give you an example for XOR. See, basically this part of means video you can skip if you are just preparing for the exam, but if you want like exactly how XOR works, you can watch this. It's just 1 to 2 minutes. Okay, see, if I have the 3 here, okay, 3 is 0 1 1. Okay, and what is 2? 2 is 0 1 0. I'll do 3 XOR 2. Okay, so what do I get here? XOR value is 0 0 1. What I got? 1. Okay, so suppose that the message I have to send is 3. Okay, from person A to person B, and the key is 2. Okay, so I got, after the XOR operation I got 1. So 1 will be transferred from A to B. That is not the real message, is the encrypted message. Okay, how will the decryption happen? For decryption again I have to use the key. Okay, so when I use the key, what I will do, 1, which is 0 0 1, again I will do the XOR operation with 2. So what is 2? 0 1 0. When I do the XOR operation, what do I get? 0 1 1. This is what? This is 3, right? That's the same message I had to transfer from user A to user B. So see, as you can see, the message is transferred and the text was encrypted in between. So this is how the XOR this is how the all cryptographic techniques work. Okay, so this is the diagram which you have to make from server A to server B. The message will be encrypted and it will be sent, okay, from different routes. And there are 2 types of encryption. The first is the secret key or the private, and second is the public key. Here one key will be used which will be known to the sender A and the receiver B, and public key will have 2 keys. In that A will be having different key and B will be having different key. Okay, so public key is encryption is more secure, but it is time taking. Okay, whereas in the private key it is the opposite. Okay, and authentication techniques, there are two techniques: authentication of the by using the message digest and by using digital signature. Okay, these two are the authentication techniques. And the examples of secret key encryption protocol, this comes under cryptographic techniques. The first is the DES, data encryption standard, AES, advanced encryption standard, RSA and Diffie-Hellman. So we'll be discussing each of these one by one. And the next question is, what are the steps involved in DES? See, there are 4 things, right? So we'll be discussing DES first. We'll be seeing the theory, and after that we'll be doing one numerical. Okay. So what is the theory? What are the steps involved in DES? DES means data encryption standard. Okay, so here it has 64-bit input. Okay, input is how much? 64-bit, and the output is also 64-bit ciphertext. That means encrypted one. Okay, so it contains 19 steps. The first is the initial permutation, and the last is the final permutation. In between that we have 16 iterative steps and one 32-bit swapping. So this is the diagram which you have to make. This diagram, in this the input is 64-bit and the output is 64-bit ciphertext. Okay, and initial permutation, final permutation, here we have 16 iterations, 1 2 till 16, and after that we have 32-bit swap. Okay, after making this diagram, explain what is the iterations, what's happening in the iterations, and how is the key generation happening. Okay, so let's discuss that. How much is the input? Input is 64-bit. It will be divided into 2 parts, Li and Ri. Okay, left input and the right input, 32-bit. Okay, and in the same way the key will also be divided. Key is how much bits? 56 bits. It will be divided into 28 and 28. Okay, in each iteration it will be rotated and it will be provided to the next iteration. Okay, and these are the two formulas. Li is equal to previous value of Ri, Ri is equal to previous value of Li XOR F. What is F? F is this one. So this one, what exactly it is, we will be discussing in the numerical. Okay, and so the F operation is also there. You can go through it. We will be discussing in the numerical how exactly F operation happens. So you have to just write this one and make this diagram. Okay, this diagram also you will understand when we will solve the numerical. Okay, and this is the numerical here. We have in the round 4 of DES, the message L4 is this one and R4 is this one. So what is given to us? L4 and R4, and along with that the K5 value is also given. Okay, so these are the things which is given to us, and what we have to find is R5 and L5. Okay, so the formula is Li is equal to Ri minus 1. Directly we can do. L5 we have to find out. So L5 will be equal to R of 5 minus 1, which is R4, right? So R4 value is given to us in the question. This is the R4 value, that will be equal to L5. So half of the question is done. The next half is about R5. What is the formula of R5? Do the XOR operation between R4 and K5. Okay, this is R4, this is K5. Do the XOR operation between these both, and that answers XOR should be done with L4. So basically what we are doing is we are just doing the XOR with this one and this one, then finally doing the XOR with this one. That is the value of R5. Okay, which you have to find out. So let's do the XOR operation between R4 and K5. Here are some changes you have to make. See, you can observe here. Here you can see here 8 digits are there, right? But here it is more than 8, right? 4 4 4, it is 12 digits here. So you have to make some changes to make it equal. So how we are going to do that? Okay, so what is the R4 value? It is starting from 3 4 1 2 and A90E. So it is first two numbers are 3 4. So I have written 3 here, 0 0 1 1. Okay, then leave a gap and write 4, which is 0 1 0 0. Then again leave a gap and write the third digit, which was 1. Okay, so I have written 1 here. So the gaps I am leaving is this one. How do you fill the gaps then? The gap is filled as follows. Observe here carefully. Here I have 0 0 1 1. Okay, and here I have 0 0 1 0 0. What is the last digit here? It is 1. What is the first digit here? It is 0. Swap it and write it here. 1 0 swap, 0 1 I have written here. Same thing goes for the next one also. This is 4 and this is 1. Okay, here I have 0 and here I have 0, the first one. swap it, it will be same only right here. Okay, same thing goes for the between all the different digits. After you have done that, just add 0 at the last and 0 at the first. Okay, and now it is 48 bits. Then write K5 value, convert this into the binary value and write here. Okay, here. After you have done that, what is your next step? You have to do the XOR operation. Do the XOR operation for each of these bits, then you will obtain this result here. In this result, you will do exactly what you had done before. You had added zeros here at the starting and ending. Now you will remove the first and the last digit. After that, leaving 4, you had added 2 things, remove that. Whatever I have underlined here, that is to be removed. After removing, write the means what is remaining 4444 chunks that you will be writing here, and that is the answer of this one. Then what you have to do, XOR with L4. Okay, what you will do, XOR with L4. L4 value is here, convert it into binary and write here below this one. This is the answer of R4 XOR X5, R4 XOR K5, and L4 value you will write here. After that, do the XOR operation between each of these and write the hexadecimal value, that is the value of R5. Okay. The next one is AES. See here, DS theory we have discussed, the numericals also discussed. Next one is AES. It is asked means very less times in exam, so if you want you can skip this one. Okay, so basically it's very easy. AES, what we have, advanced encryption standard. Here it's more powerful than the DES. The first thing is the input is 128 bits. Previously it was 64, and the number of rounds was 16. Here it is 10 to 14. It's variable. Okay, and there are 4 rounds. So in the 4 rounds, S box is the first one. Second is the shifting of the rows. Third is the mixing of the columns, and fourth is the add the round key. Okay, 128 bits input, 128 bit key input, and here we have 4 steps. So let's go through 4 steps briefly. It's the first one is S box. S box is basically a non-linear bijective function which is written here. It's defined as follows, and the second is the shifting of the rows. Here we will shift the rows, means in the first iteration we will shift by 1 position, second iteration by 2 positions, and so on. And the third one is the mixing of columns. So it's just that the columns order will be changed, and fourth is the added the round key. In each iteration the key will be added. Okay, so this is basically it. You just have to write these steps if they ask in the exam, and after that the first part is over, which is the private key encryption protocols. Okay, the next is the public key encryption protocols. Here in both we have the algorithm and the numerical. So let's discuss the first one. The first one is the RSA. So explain the key generation, encryption, decryption phases in RSA algorithm. Illustrate with an example. Okay, so key generation, the first two are see this one we had in the lab program also, right? So it's a bit easier than the next one. So choose 2 prime numbers p and q, multiply to find n, find phi of n as p minus 1 into q minus 1. After that, find the GCD value. Okay, this you will understand when we will solve some questions. And after finding GCD value, you will get E. Find the D value using E into D is equal to 1 mod phi of n, and that's the key generation. And after you find D, to encrypt it, use plain text power E mod n. For decryption, cipher power D mod n. Okay, so let's see an example. If m is equal to 9, that's the message to be transferred. P and q are 2 prime numbers, 3 and 11. So find n value, which is 33 will get. Find phi of n, 3 minus 1 is 2. 11 minus 1 is 10, 2 tens are 20. Find the GCD value. How you will find is, you will start from 2. 2 and 20, it's divisible, ignore it. Then go to 3. 3 and 20, it's not divisible, take the value of 3. Okay, so E will be equal to 3. Whatever value you get here, that's the value of E. After you get E, find D into E is equal to 1 mod phi of n. Okay, so here keep on putting the values of D, like D is equal to 1, 2, 3, like that you have to put. Okay, and when you put the values, whatever value you put, suppose that you put 1, so what it will be, 3 ones are 3, then divide it by 20. What is the remainder you will get? Not the quotient, remainder you get as 3. What if you put D as 2, then you will get here 6. 6 by 20 is also remainder is 6. Like that you will keep on doing, you will get the D value as 7. In 7 you will get 21, 3 sevens are 21. divided by 20 you will get the remainder 1, right. So the selected value for D will be 7. After you have selected D value, apply two formulas. M is the message to be transferred, which is given here as 9, and N is the means P into Q, which is 33. Okay, so that you will write here by using this formula and find out 9 cube mod 33. What is 9 cube? That value will do the mod 33 with that. I mean, what you have to do is 9 cube. Okay, what is 9 cube? 9 into 9 into 9. You will do in the calculator, and then you divide by 33. Okay, whatever answer you get, you will get like something. If suppose that the answer is 721. Okay, 721.56. Suppose that you got this answer. Now what you have to do is just take 0.56. Okay, taking 0.56, multiply it again by 33. What answer you get, you write here. That is the remainder. Okay, but in some cases we can't directly do, like for example 3 power 7, if we can't directly do in calculator, at that time what we have to do is we have to divide this into many parts, like 3 power 2, 3 power 2, 3 power 2 and 3. What is 3 power 2? 9. 9 into 9 into 9 and into 3. Okay, now you have to do individually, like 9 mod 33, again 9 mod 33, 9 mod 33, then 3 mod 33. Like that, will individually when you do whatever answer you will get, write those answers and multiply it again. So like that, keep on doing like the same thing what I told earlier. When you divide by 33, you will get a decimal point, take that and multiply by 33. Okay, finally when you get all the terms multiplied and the decimals multiplied, at that time you will get one answer, that is the final answer here. Okay, if you want to know exactly how this works, like dividing this one by means if it is like 3 power 70, at that time how you have to divide. For the explanation of this one, I have explained in the lab video of RSA. Okay, you can watch that one. So this is basically about the RSA. Let's solve one more problem. Here the message is 10. Okay, 1010 in decimal it is 10. Okay, so M is equal to 10 and A and B value is 5 and 11. So I will take it as P and Q because I am more comfortable with that, and X is nothing but public key, which is E. Okay, so we have to find out the public and private keys. Public key is already given, just find private key and show the ciphertext. So let's do it. M is equal to 10, PQ value we have. First step, find N, then find phi of N. After that, find the GCD. When you get the GCD, actually we need not find because it's already given. We have to just find D into E is equal to 1 mod phi of N. Here we have 3D is equal to 40, means multiply 3 with D value and divide by 40 to get 1. Okay, so here you will get the value of D as 27. If you want to know how actually we got 27 here, there is a formula. Okay, that you please watch the video of RSA. Okay, and in that I have explained in detail. Okay, and after you get the value of D, just find what is the ciphertext and plaintext. M power E mod N and cipher power D mod N. Here you will get the same answer as previous one. The 10 was the message which was initially sent, so I am getting 10 here. Okay, so that's it for the RSA, and here also you will be doing the same thing. Basically you can go through it. And coming to the next one, which is Diffie-Hellman key exchange protocol. Okay, so here let me tell you by an example. Firstly, you will be given two numbers. Okay, let's go to the example first. The two numbers will be given, R or P, it will be given as the value will be given any number here. Here it is 53, and G will be given as another number. Here it is 2. Okay, and A and B value will be given. What you have to do is you have to write the formula first. G power X mod R, G power Y mod R. Okay, now what is X and Y? X and Y is nothing but this one only. A is X, B is Y. What you are doing is 2 power 10 mod 53. This is the value of R, this is the value of A, this is the value of G. Remember this formula? You just have to substitute the values and find out the mod value. Same thing you do here also, and after you get these two values, what you have to do is exchange. Means 31 will be taken here, and raised to 10 mod 53 is same as the previous one. 17 will be taken here, raised to 33 mod 53 will be the same from the previous one. Find out the answers. If you get the same answer, it is the correct one. Okay, and what happens in man in the middle attack is when we calculate these values, then the powers are changed. Okay, hacker in the middle changes the powers, like we are doing for 10 here, right? But what hacker will say is it is 4 and 32. So instead of 10 and 7, what we will do is we will take 4 and 32. So we'll calculate with 4 and 32 and get the different answer. So this is the man in the middle attack. Okay, so let's go through the algorithm. Here we have two numbers which are p and like how you understood, write in that way only. Write the formula. After calculating the formula for y1 and y2, the values are exchanged. Y1 will come here, y2 will come here, and y1 will come here. Raised to x1 from the previous one, raised to x2 from the previous one. These two answers we will get as same, k1 and k2. It can easily be proved that the two keys k1 and k2 are equal. Okay, so that's all what you have to explain, and this is the example. So that's all about the Diffie-Hellman algorithm. And coming to the authentication techniques. Okay, so the main technique is the SHA algorithm. In SHA algorithm, you will have an input. In the by using that input, you will produce a message digest. That is nothing but h of m. Means by using a hash function, you are producing some value. That value is known as message digest. Okay, and in this you will have 5 registers, R1 to R5. So see the diagram here. We have an input here. That input will be padded, or means it will be made to a standard size, and there will be 5 registers here. Okay, 5 registers. First 4 registers are for the iteration, last one is for the final calculation. Okay, here total the number of iterations are 80, which is divided into 0 to 19, 20 to 39, 40 to 59, and 60 to 79. Okay, so round A, B, C, D, E are used, and after that we will get the output here. So this is how SHA algorithm works, and each time we will be providing the different keys. Okay, so that's all. You have to make the diagram and explain this one. And coming to the firewalls, firewall is what? It is just protection from the outside world, means from the hackers. Okay, you can install it in your home as well as in the you can use in the company. So if you are using in a company, you can change the modifications of it, and means suiting your company. So this is the diagram: users, firewall, and the internet. Okay, firewall comes in between the users and the outside world, and it could be used to maintain the data traffic. And how does firewall work? Mainly 3 techniques: packet filtering, and by using IP address, and by using denial of service. Okay, it controls the number of packets entering a network. So this is basically it about the module 4. Let's see what is in the module 5. In module 5 we have a few topics. Let me note down that one. The first is the audio and video streaming, the properties of audio and video streaming. Okay, that's the first topic. After that we have the categories of streaming stored video. There are 3 categories: UDP, HTTP, and dash. Okay, adaptive HTTP is nothing but dash. Okay, so that's the second topic. And after that we have CDN. CDN is the content distribution network. Okay, here we have the example of Netflix also. If they ask, you have to make the diagram for the Netflix architecture and explain that. Okay, after CDN we have the limitations of best effort IP service. Here we have 3 limitations: the packet loss, packet delay, and packet jitter. In packet jitter, the most repeated question is about how can we remove the jitter from the audio. After the IP service is done, the next one is about the 2 loss anticipation schemes. Here we have FEC and interleaving. These are the most repeated questions. Okay, interleaving. And finally we have the RTP and SIP, real time transmission protocol, and session initiation protocol. Okay, so that's all we have in the module 5. Let's go through each question one by one. So the first question is, what are the properties of audio and video? So the property of video, like in the notes you have in lengthy one, but for exam you have to remember these 4 points. Okay, it is like a very high bit rate, because one video consists of many images, and each image has many pixels and bits in it. So it is of high bit rate, and it consumes a lot of bandwidth, because obviously it's high bit rate, and the space ranges from 100 kbps to 3 mbps, and it could also be compressed. Okay, so there are some techniques of compression which you can learn by your own. Okay, and the properties of audio: it's less bit rate, it has lesser bandwidth, the size varies from 100 to 128 kbps, and it's analog signal first, which is converted to digital signal. Okay, and here also the steps involved in the transformation are also discussed, which are quantization, encoding, decoding, and sampling. Okay, so basically you have to explain these things in your exam, and make sure you go through notes to get more information regarding these. Okay, and that was the first point. The second is the types of streaming the stored video. The three types: UDP, HTTP, and adaptive HTTP. UDP means it makes the video into chunks and sends it. Okay, so it does not have the error congestion control mechanism like in TCP, and they maintain a separate connection for sending and controlling commands. Okay, sending control commands. Okay, so from one link they will send the videos, means data. In other link they will send the control commands. Okay, and one of the limitations of UDP is that it cannot provide continuous play out, because due to variable amount of data being sent. Means suppose 100 packets are sent in first iteration, second it will be just like 70, or it will be like 20 also, so it will not be continuous. Okay, so that's the first limitation of UDP. Coming to HTTP, it's the videos streamed through the web page. So what happens is, in a file, video stored in a file in the HTTP server, when we are accessing it, it is provided a URL, and a URL is sent to us. We'll access that URL then. Okay, that is the basic operation of the HTTP streaming. Okay, and it uses TCP, so it's reliable, and the client collects packets, and when it's possible it starts streaming the video. Okay, so this you can observe in YouTube. In YouTube, when you play any video, at that time in in the timeline what you have is the red bar will be there, and you have a gray bar also. That gray bar is nothing but the packets are coming and it's getting collected here. When it's sufficient packets are collected, it will start streaming the video. Okay, so that's basically about the HTTP streaming. And the last one is the dash. Okay, dash means dynamic adaptive streaming over HTTP. In this here just remember that in we have different versions of the same video, right, like 360p, 480p, 720, and 1080 and so on. Okay, so these versions are nothing but by using dash we will be accessing them. Okay, so it accesses dynamically. What happens is HTTP will see whether the bandwidth is means it's more, and whether the client's internet is more speed. At that time the quality will be changed based on that. If the internet quality is low, the video will not be stopped. What will happen is the quality will be changed. So the video will still play, but in a lower quality. So that's what the changes happen dynamically. That is known as dynamic adaptive streaming over HTTP. Okay, so that's what happens. Dash can often achieve continuous playout at the best quality possible. Okay, and the next one is explain how the DNS redirects the user's request to the CDN server. Okay, so let me explain you what actually happens in why is CDN needed. Suppose that there was one data center here for the whole world. So what happens is, if I access like there are 3 movies, A, B and C movies are there. Okay, and here are users present, and this user wants movie A, he wants B, this user wants A, C, A, B, B, A, C, A, C. So see here, which all user wants A, what we have to do, we have to establish a link and send A. This user also wants, we will send A, here also A. So there are many links established here for the same video. Also the distances are mattered, like for sending from this to this, suppose that it's costing $12. So again from here to here it will cost some more, here also it will cost some more. So what does CDN do is, CDN will make a group of these people into location 1, location 2, location 3, and this is location 4. In each of these, the one time the copy will be sent. Copy of ABC will be sent here, it will be stored in a separate server. ABC, ABC here also, and all the groups will have their own servers. So whenever they want, they will just access from here, a shorter distance and faster access. Also the cost is reduced because see bandwidth is less, I mean the distance is less. So for each group the copies will be used to transfer to the group members, right. So this is known as CDN, content distribution network. The content is distributed in the network. Okay, that is CDN. So I have discussed the limitation, why CDN required, and how CDN works. Okay, so that's all what is in the CDN. And suppose that take an example here. In exam you have to explain this one. A user will request means a server which is the netcinema.com. okay, netcinema.com is a website in which the user is requesting to send the data. Okay, this is a user who is sending the request to netcinema.com. okay, so when the request is sent from here to here, the first he will send the request to the local DNS. okay, means the local DNS will see if the movie's data is already present in it or not. If it's not present, then the netcinema's authoritative server will be checking the data. okay, after finding the data, that will be transferred to the nearest CDN. okay, and before that, who will be transferring the data to the nearest CDN? The CDN's authoritative server. okay, so the nearest server will be chosen, the HTTP link and the URL will be sent to the CDN server which is nearest to the client, and from there the data will be sent to the user. okay, so see, it's very simple. The user will be accessing the web, and from that the request will be sent to the local server. If the data is not present locally, then it should be sent to the it should be fetched from the website. So website's authoritative server will see if the data is there. If it's there, it will inform the CDN's authoritative server. So CDN's authoritative server, what it will do, it will see which of the CDN server is nearest to the user, and it will send the URL link to that, and from that server the file will be sent to the client. okay, so this is how the CDN server works. And if they ask for the specific example of Netflix, you have to draw this diagram here, and here also the same thing happens. The client will be registering with the Netflix server, and from the Amazon cloud, whichever the movie is requested, for that the manifest file is sent to the client. Manifest file means it has the information about the movie, and after that the quality is also chosen, and the nearest server will be contacted, and from there the video chunks will be sent to the client. okay, the next question is regarding give the limitations of the best effort IP service. Best effort IP service means what? It will make the effort to deliver the data, but the limitation is that it is not means 100% sure that it will be delivering the data. okay, it can be due to three reasons. The first is the packet loss. The packet loss can happen if the data is sent and it's lost in between because it's UDP, and that was about the first one. Also, if the the buffer is full, at that time if the another extra packet comes, it will be rejected. So there the packet loss can happen. The second is the packet delay. Packet delay means it can happen due to the following reasons: the transmission, processing, queuing delay, and propagation delays, and the processing delays in the end systems. okay, so due to this the packet delay can happen, and the jitter is nothing but the varying delays. okay, varying delays, the packet delay is just the delay, and jitter means that varying delays. That means sometimes 150 ms delay, and after that 400 ms delays. That is the packet jitter. How can the packet jitter be removed from the audio is the next question. okay, here basically the two techniques are used. The first one is the timestamp. Using the timestamps, the order will be maintained and the packet jitter will be reduced, and delaying of the playout chunks at the receiver. okay, so here what happens is, suppose that two persons are doing a video call. okay, and there is a delay of 150 ms. So a delay of 150 ms and below that is not perceived by humans, but if it is more than 400 ms, at that time the data which is queued in between will be discarded. So the data which is in between will not be sent to the receiver, but the data after that will be sent to the receiver. okay, so that's all what happens in the playout delay. The discarding of the chunks will happen in between the sender and the receiver. So this is how the jitter between the sender and receiver is removed at the receiver's audio. okay, next question is what are the two loss anticipation schemes. okay, so basically what is packet loss? A packet loss is if it never arrives at the receiver, or if the packet arrives at the receiver after the scheduled playout time. okay, in these two cases the packet is considered to be lost. So how can we use the techniques for loss anticipation schemes? The first is the forward error correction. So here let's see an example and you can explain by yourself. Here you can see 1, 2, 3 and 4. These 4 are the packets to be transferred. So what happens is the duplication of the packet. 1 will be here also and with 2 also. 2 will be here and with 3 also. 3 will be here and with 4 also. So if any of the packet is lost, the remaining the other packet can be retrieved. For example, here 3 has been lost, but it can be retrieved from here. So that's what the duplication happens in the forward error correction for the retrieving of the lost packet. Okay, and interleaving means the order will be changed. Okay, for example, if the order is 1 2 3 4 5 6 7 8 9 10 11 12 and 13 to 16. So how the packets will be there is 1, then 5, 9, 13, that is the first packet. Then second packets 2, 6, 10 and 14. So in second packets, the second bit of each of these chunks will be maintained. The third is for the third bits, and fourth is the fourth bit. So what is the advantage is that if any of the packet is lost and rearrange the schemes, at that time what we get is 1 2 and in between it's lost, and it is 4 after that, and that is the first packet. And here also we have means 3 packets are there, 1 packet is lost. So from each of these only 25% is lost, right? So still we can know what actually is happening in the video, right? Means a bit of quality will be reduced, but we can know the overall picture in the chunk what is happening, right? So instead of getting this high quality and losing this totally, it's better that we'll get all of low quality, but we'll get all packets. Okay, so that's what the interleaving means, and this about the two loss anticipation schemes. Okay, so the next one is about the RTP and SIP, and this is the last question in module 5. So RTP is just as a protocol, real-time transmission protocol. It can be used for the sound and the video also, and it runs on top of UDP. So you can remember this diagram here. This is a packet, and above that is RTP, and it is sent through UDP. Okay, so RTP, what is the main advantage is that before that it has 3 things: type of audio, sequence number and the timestamp. And what is the advantage is that if an application uses RTP, then the application can easily interoperate with other multimedia applications. That is the advantage of RTP. Okay, the next one is the SIP. SIP is session initiation protocol. So consider an example here between Alice and Bob. Alice will send an invite link to the Bob, and Bob's phone will ring here, and Bob will accept it. So 200 OK will be sent as an means the code when it's accepted, and that code will be received by Alice. Then the connection will be established. Alice will send an acknowledgement. Here the low audio will be used, and from the GSM it will be like this. Okay, so basically there are 4 steps. Alice sends an invite message to Bob. Bob sent an SIP response 200 OK. Then Alice will send a acknowledgement message, and finally Bob and Alice can talk. Okay, so the things which you have to mention is, what are the functions? It is used for establishing the connection between caller and callee over an IP network. It allows the caller to notify and verify who is on the call, and it allows the participant to agree on the media encoding, and it allows participant to end the calls, and the IP address is also verified before the calls. And that's all basically about the SIP protocols. So that's all what you have to mention in the 2 points of RTP and SIP. Okay, and make the diagram for each of these. Okay.